So good afternoon, everyone. It's a pleasure to be here with you today. My name is Degoncir Gonçalves, and everybody calls me Dego because we all think it's easier. First of all, we'd like to thank Team Florida for the opportunity to be here in this webinar section today. In special, we thank Brad Apple and Barbara O'Connor for the excellent job they have been doing to promote Team Florida and the professionalism they took care of us during the preparation of this seminar. I also would like to thank Intercom Company for accepting our invitation to be part of this webinar. We have been working with Intercom for a long time and now in the United States as well. We are so proud of working with this amazing company which keeps seeking high quality and performance as we do. Thank Eric Patterson, Johnny Redman, of course, John Arnold, who work hand in hand with us to prepare the presentation you all will see today. We will present the presentation and you can feel free to send us your questions anytime using the chat or Q&A bottoms. We will dedicate 15 minutes in the end of the section to answer those questions. During this section, we will ask you the 3 polling questions to interact even more with all of you guys. Today, Diego Hoffman, John Arnold, and I will present the webinar for you. Please allow me to introduce each one of us as a presenters. I'm a general manager of FTA in Orlando and a former business professor with a background in international business with more than 20 years experience in internationalization projects. I contribute to implementing an American company in Brazil, which provides CCTV systems. I help the expansion of Apple's presence in Brazil, beside the other 15 American companies in the country. I also work for technology companies from Canada, Turkey, and China. And as a consultant, I had helped companies such as Siemens, Faurecia, Aker Solutions. And I have been working in the technology sector for more than 10 years. I'm a proud member of Team Florida and also ITE, beside Florida and Puerto Rico District ITE. Diego Hoffman is an electrical engineer specialized in development and operation of ITS system with more than 20 years experience. As a head of engineering at Fiscal Tech and the leader of the the R&D, his role is to keep pushing the team towards innovation, cost effectiveness, and relevance of the applications. Leading operations, his role is making sure members of the team are able to meet the standards of the services, quality, and capability to handle more than 3,000 ITS lanes deployed so far. In addition to compliance and quick response when the matter is maintenance, the primary goal is to achieve client satisfaction. John Arnold has been the market specialist for traffic and aviation industries at Intercom for 6 years, working with portable and in-ground vehicle weighting products. He has a Master of Science and Chemistry in MBA International Business and came into the weighing measurement industry after time in the analytical instrumentation markets. John works with the standard integration and deployment in weighing motion and scale solutions for Intercom throughout the world. In addition to IBTTA, CVSA, and NCWM as a participant in the various weighing motion groups. John is a member of the Society of Allied Weighting Engineers and of the International Society of the Weighing Motion, ISWIM. During this webinar, we're gonna cover weighting motion scales and sensors, weighting motion and high-speed weighting motion systems, and weighting motion direct enforcement and tolling. I would like to give you a brief overview of Fiscal Tech. Fiscal Tech America is a software factory. We are able to develop solutions and customize them according to the client needs. With more than 25 years of experience in transportation industry, we keep pushing ourselves to innovate in the ITS industry. Even though we focus on weighing motion and high-speed weighing motion today, you can see that here we have another solutions that we develop as well. We are proud to be of being a member of Team Florida, the National Safe Council, Road to Zero, and strategically be part of a UCF incubator program to keep going with our mission for R&D. Now, I would like to introduce you to John to present the first part of the presentation. Welcome, John.
Thank you, Diego, and thank you everyone for joining us. First off, I'd like to introduce Intercomp to everybody. If you're not familiar with us, a little bit about Intercomp. We're a family-owned business just based outside of Minneapolis, Minnesota, with offices actually all around the world. And we've been in business for over 40 years with global deployment of our products, largely through dealers and system integrators, but we do some sales directly to customers. And all the weighing devices that you see and that we provide are manufactured at our headquarters outside of Minneapolis, Minnesota. And all of those devices are based on highly accurate strain gauge technology. Next slide, please. We serve a variety of different industries. And one of the simplistic things we say is, if it has a wheel, we can weigh it. You might be familiar with Intercomp in the United States for our racing scales. We sponsor NASCAR and have been their official scale for quite some time. Or aviation scales, where about 80% of all commercial aviation around the world are actually weighed on Intercomp scales through maintenance centers and manufacturers and airlines. Our experience, though, with Weigh in Motion stems from the military. About 2 decades ago, we partnered with ORNL, the Oak Ridge National Laboratory, to develop Weigh in Motion for rapid development of military units. And that technology has been commercialized and is now offered to integrators worldwide. Next slide, please. So to talk about the future of Weigh in Motion, we really want to talk about the current scales and sensors that are available. Now, the current techniques include, of course, static, fixed, and portable scales, full-length truck scales, or portable static scales. There are deployments of portable Weigh in Motion where ramps will keep the adjacent axles on level to increase accurate weighing, but we're going to focus on fixed Weigh in Motion today. And fixed Weigh in Motion can happen at low speeds, medium speeds, and high speeds. And actually, Intercomp makes almost all products or serves almost all the different techniques here that you see on this slide. Next slide here, please, Diego. Now, how to choose the proper weighing technique for Weigh in Motion? We have to start with economics. Now, economics, there is a benefit for Weigh in Motion because the cost of the equipment in the installation and the cost of ownership versus static scales can be significantly less. So this is one benefit when it comes to initial costs for CapEx and then, of course, cost of ownership over time. Efficiency is clearly a benefit for Weigh in Motion, where we can weigh vehicles in motion without stopping them. So efficiency is a part and parcel of Weigh in Motion. And safety, I put third because I'm a fan of Mike Rowe of Dirty Jobs and Dangerous Catch fame. But efficiency and safety have benefits to multiple parties, and we'll pull that over to the benefits include roadway operators, benefits to vehicle operators, understanding the weight of the vehicle in out of service conditions. The enforcement officials wouldn't necessarily have to stop vehicles if they're using Weigh in Motion more efficiently, and the benefits to society and the economy of having an infrastructure that's protected by Weigh in Motion, understanding the commercial vehicle traffic over our infrastructure. But of course, the performance of WIM devices have progressed greatly from 20 or 30 years ago, or even 10 years ago. So that performance has allowed for increasing applications of use of Weigh in Motion, which includes potentially compliance and legal requirements, which Fiscal Tech is going to talk a little bit about today as well. Next slide, please. Now, to understand the legal framework and performance framework that Weigh in Motion devices are looked at, I'll try to keep this as simple as possible. There is no global standard that's accepted for HSWIM. There's a high amount of overlap between these standards with regards to site specifications or even performance specifications and how things are looked at. But that can differ by state, by region, by country. One might be familiar with performance standards such as COS 323. They have different categories for accuracies, A5, B7, B10. Those are gross vehicle weight accuracies, those numbers. In the United States, we look at ASTM E1318. People might be familiar with type 1 or type 3, which is 10% accuracy for gross vehicle weight or 6% accuracy for gross vehicle weight. That's typically how we evaluate high-speed weigh and motion systems in the United States. And that evaluation includes looking at factors such as gross vehicle weight, axle weights, groups, and spacings. They all have parameters that must be met for that performance. That differs from metrological standards, such as OIML R134 and the International Metrological Standard, or of course, in the United States, Handbook 44, the NIST standards that the National Conference of Weights and Measures helps manage. And there's other international standards, such as PCT, the GAUSS standards for the Russian Federation. Now, certifications, there's really type certifications, and this is where independent labs or laboratories would ensure the weighing devices meet the metrological standards. And here we see some different organizations depending on what country that you might be in. OIML, NTEP, we might be familiar with in the United States. In Metro is Brazil, and PCT, of course, for the Russian Federation of States. These are just examples. Okay, go next slide, please. Probably the largest difference between performance standards and metrological standards is performance really focuses on the different categories and what errors are allowed in them. Whereas metrological standards, be they international or national, it's really for legal, for trade or enforcement. We're really trying to look at a device and understand how we can draw some lines in a legal framework around it for certain things. The difference, one of the biggest differences that I just want to point out here is the confidence interval versus maximum permissible error. When you use something for legal applications or enforcement applications, maximum permissible error is usually what's used. And that means the type certification of the device, the performance is not allowed to go outside the accepted window. So if you even have a single vehicle run outside the accepted window, then that type certification would not be issued to that device. Whereas COST and the ASTM allow some 5% of the vehicles, if you run 100% or 100 vehicles, to be outside of that range. So there's some of the differences between performance and metrological. Next slide, please. But what are some of the obstacles that weigh and motion is up against? Doesn't matter what sensor or what system that you have, there are some things that need to be overcome by a weigh and motion system. First and foremost, of course, are environmental and site conditions that can contribute to vehicle dynamics. And as I mentioned, these standards actually have pavement recommendations to give the best possible surface smooth and flat, to give the best possible performance by the weigh and motion system. Both of those can affect vehicle dynamics as well as the vehicle suspension itself. So all of those things can add error to the total observed error when it comes to the performance of a weigh and motion system. So as the sensor performance has decreased the amount of error over the past decades, the amount of error that environmental and site conditions and vehicle conditions contribute has grown as a relative ratio. So it's something that we want to take in consideration to understand where weigh and motion can be used and how we can overcome some of these conditions, such as vehicle dynamics caused by different conditions. That, of course, would affect your sensor selection, your experience with different sensors and their experience overcoming some of these obstacles, and what value you place in the data that comes from weigh and motion systems. You don't want to overbuy or underbuy for a particular application, of course. And legislation in whatever country or state you might be in, that legislation can really channel what happens or what applies for direct enforcement or legal for trade. Okay, go next slide, please. So I'm going to generalize, at least here, for two types of in-ground weigh and motion. We have multiple types that intercount, but there are frame-based scales, and then there are sensor-embedded type sealed scales or sensors. Frame-based scales, in this particular case, an LSWIM or a low-speed scale, can be highly accurate. It's a very small footprint in civil works versus a static scale. It can be placed in newer existing lanes. The nice thing about some of these is simplified maintenance, ease of access to load cells or the drains. And this particular scale has certified performance. Internationally, this is OIML R134 Class 2 certified, which means it met 1% gross vehicle weight error, maximum permissible error at certification with 90 vehicles, 3 different types. Pretty extensive testing. Strip sensors, though, is primarily what people are using for high speeds. This, of course, is now hermetically sealed sensor. And it has a very wide speed range. You can use this at 3 miles an hour to 100 miles an hour. So about 3 kilometers an hour to 120 plus kilometers an hour. You can install this in the same day by cutting channels and grouting it into the existing pavement, which of course requires minimal maintenance ongoing. And this too is certified by independent labs to OML certifications. There you go, next slide, please. Focusing in on those strip sensors, they are based on strain gauge technology. So that gives one a stable, temperature-controlled, compensated measurements, which can be nice in a variety of different environments. The installation is somewhat rapid, along with other sensors of similar form factor, and no drains are required. The way Intercomp supplies these is open integration. We can supply this through our electronics or directly into system integrator electronics. So our intent, Intercomp's intent, as manufacturers to provide these sensors to a variety of system integrators. These give wheel weights. You can see they cover half the vehicle lane and supply left and right wheel weights. And as mentioned, they're certified performance to international standards, Class 5E and 10F, which means they gave 2.5% gross vehicle weight maximum error at medium speeds and 5% maximum error at high speeds, actually, with no flyers above those. These sensors are used in a variety of different applications. As you see down here, data collection, for example, uses 2 of these sensors. Pre-selection or screening, which is widely used in the United States, would use 4 sensors in a dual threshold installation. And enforcement or tolling or border patrol, not border patrol, but border sites, border crossings, can use 4 or 6 sensors in a dual or triple threshold. And we've seen some lower speed enforcement and screening for industrial screening, for example, at terminals or intermodal terminals, for highly accurate and low maintenance sensors. They use 6 or 8 sensors or 3 or 4 rows of the sensors. There you go, next slide, please. But what is the data from the weigh and motion sensors, and what does it look like now, and what will it look like in the future? Well, of course they give you weights, gross vehicle weight, group axle, and wheel weights. Counting and classification can be done with a variety of different sensors, in-ground sensors, and even above-ground sensors. But once you have in-ground sensors, in addition to speed, spacing, and classification, you can also get the weights. And something that's a lot more common nowadays with weigh and motion sites is identifying tire anomalies, where you have missing flat and underinflated tires. This clearly is a safety issue for the operator that they might be unaware of, and it also increases the amount of pressure the remaining tires place on the roadway surface. So in fact, in-weight gross vehicle weight and in-weight axle weight will actually be overweight when it comes to the pressure that's putting on the infrastructure. But the weigh and motion data is most valuable when it's integrated. It allows people, which is done in the United States, to bypass weigh stations or bypass certain things, which can be done, even bypass toll stations, for example, because you're automating that based on the weight. And bringing up tolling, you can transact by tolling by weight. And that adds some fairness and parity to the industry, such that an 80,000-pound truck can be charged more than a 40,000-pound truck, because they're using the road more with regards to the weight of the vehicle. I mentioned out of surface. This, of course, applies to the safety of the operators. I put it third again to be consistent with Mike Rowe. And moving on to compliance, this allows for permanent licensing checks, of course, not weigh and motion, but now we're above ground with OCR cameras or DOT cameras to check that versus databases. So this can all be automated. Part of that automation can include direct enforcement, which is happening in a lot of parts of the world that Fiscal Tech will speak to. And with the oncoming vehicle-to-vehicle communication and vehicle-to-infrastructure communication, to meet the performance requirements of some of these upcoming applications, one of the ideas is, one idea that is kind of bandied about, is using onboard mass, where there are some commercial vehicles with onboard mass, using that mass of a vehicle to speak to the WIM infrastructure and dynamically calibrate the system if required on a daily, weekly, monthly basis. So you know the performance of the weigh and motion system is maximized throughout its life. There you go, next slide, please. So we're talking about the future of WIM. And I say beyond the WIM, by the way, is of course an acronym, but I'd like you to consider below the wheel and beyond the wheel. Below the wheel, of course, a weigh and motion system can give you wheel axle groups and gross weights. And as mentioned, you can identify tire anomalies and their conditions for the operator. Counts and classifications can be done by a variety of different technologies, including above ground technologies, which can happen in the future, but weights can only be delivered by crossing over a sensor. And data collection, by incorporating weights into data collection, people can better understand and plan for what they want to do with that particular location. Now that I've spoken as a manufacturer of scales and sensors, of course, the future of weigh and motion, I feel, is beyond the wheel. And what that means is you take that weigh and motion data, and the system integrators and network operators can incorporate that weigh and motion data to truly maximize its value. This is where system integrators can automate transactions with efficiency and fairness. One can automate enforcement. This can all improve safety of the roadway officials and of the operators themselves. And integrating that data into a system and then disseminating that data and using it in the best and most efficient possible way is truly where the value of weigh and motion will be, is now and will be in the future. There you go, I hand it back over to you.
Okay, thank you very much, John. And now I just want to kindly ask you to respond to one of our questions here we have here in our poll, and I just give you some times to everybody just respond, because these are very important for us, because we identify some obstacles to implement the high-speed weigh motion, and it's very important to hear you all about this type of feeling that we have. So if you could please respond that, and then you can see the result.
Okay. Diego, I'm going to put the polling question up. This is Barbara. You do have 2 questions in your Q&A. Do you want to answer them now or later?
No, later.
Okay.
10 minutes later.
All right.
Oh, so good. Yeah, we can just give a little more time, and then we can just finish, I think. Actually, you can pick more than one, just for guys. Okay. I think that's it. Barbara? I just closed the window, Barbara?
Yeah, it looks like you've got about 63% have voted. So
okay. Yep.
You can take a look at the results here.
Mm-hmm. Yes. Very good. Okay. Maybe we can move on. Perfect. Okay, go back to our program. And now we're gonna share this video with you all.
The Fiscal Weighing Control complies with the most modern technology in integrated cargo vehicles weighing systems. It identifies, classifies, and checks the weight of vehicles with high precision, up to 130 kilometers per hour, 80 miles per hour, on par with the European standard for roadway in motion. A complete system with many advantages. Highly customizable and integratable. Includes laser scanners capabilities by lane, checking all passing vehicles, measuring height, width, and length for an accurate classification. Uses individual radio frequency identification, RFID reader for each monitored lane. High-resolution panoramic cameras for a clear visual identification. Performs complete vehicle classification of all cargo and passenger vehicles. Cameras for automatic license plate reading, including the recognition of the new Mercosur standard. Other license plates layouts can be quickly adapted. Detects vehicles whose drivers disrespect instructions or road signs, keeping record of infractions. Full integration with existing weighing stations, optimizing costs and taking advantage of pre-existing investments on infrastructure and other systems.
And now I wanted to introduce Diego Hoffman to continue the presentation. Welcome, Diego.
Thank you, Diego. Thank you all for joining us. I'm going to continue the presentation, and I'm going to give more detail about high-speed weight motion, about toll by weight, and about HS direct enforcement. Next, Diego. So what is high-speed weight motion? Oh, it's important to clarify the difference between high-speed weight motion and other types of weight motion. Diego, I believe the presentation was, you have to share your screen again.
There you go.
All right.
Correct.
So it's important to clarify the difference between high-speed weight motion and other types of weight motion. The main difference is that weight motion at high speeds is performed directly on the highway at normal traffic speeds without the need for speed reduction. A wide set of information is collected from each vehicle, such as total weight, each axle weight, speed, vehicle dimensions, axle spacing, vehicle classification, identified license plate by the OCR, date, time, and other information. Currently, weight motion at high speeds is widely used for pre-selection before weighing station, and also for statistical purposes. The traditional weighing stations usually has a low speed weighing motion scale or static scale. This is the most common case in the United States. According to the Federal Highway Administration, it is estimated that 67% of trucks on the road in the United States travel with their fuel volume capacity or cubic capacity reached before the weight capacity. For those trucks, maybe this time consuming of entering the weighing station can be avoided. Next, Diego. As you could see on the video, it shows a real case implemented in Brazil, in the interior of the state of São Paulo. The toll operator that manages this highway is called Entrevias. The total stretch of concession road is about 360 miles. It's an important corridor for the economy in Brazil. We have 4 sites completely installed and fully operational. 2 other sites are under construction with operations planned to begin in 2021. This is the most complete high-speed weight motion solution currently in operation in Brazil. Next, Diego. Let's talk about the system features. Why do we call this case a complete high-speed weight motion solution? Basically, because all cutting-edge technology and functionality are present. Following the traffic flow on the road, there is a first gantry where weight in motion occurs at high speeds, up to 8 miles per hour. 2 rows of intercom, strain gauge, strip sensors are installed on each lane. With this, we achieve the accuracy class A5 of the COST 323 standard. For better vehicle detection and classification, there are also inductive loops and piezoelectric sensors for dual tire wheel detection. We have individual cameras per lane for image capture and automatic number plate recognition. For the night and low light condition, we have auxiliary infrared illuminators, invisible to the human eyes. There are also radio frequency identification tag readers. This is used combined to ANPR or OCR for vehicle identification. We also have high resolution cameras for overview or a panoramic view of the vehicles positioned in a side angle, allowing the visualization of the vehicle's characteristics and also allowing the visual confirmation of the automatic classification made by the system. A little further down the road, following the traffic flow, we have another gantry equipped with full color LED screens, as you can see on the picture on the center. These screens are used to indicate to the drivers whether they can bypass or whether they must proceed to the weighing station for further inspection. If the driver disrespects the indicating message and do not enter the weighing station, there is another gantry right after the station entrance, as you can see in the picture on the top left. The equipment on this gantry will read again the license plate and the RFID tag, and will catch the offender by capturing pictures for violation evidence. Completing the system, we have a LiDAR scanner for each lane that permanently scans the profile of the vehicles using a rotating laser beam. It allows accurate measurements of vehicle dimensions, including its height, width, and length. Next, Diego. About the software solution. The software solution is our great contribution to the entire system. It's what goes beyond the wheel. We are specialized in software development. It integrates all the information collected in order to allow automated and centralized control and monitoring. The software is based on a web interface and is highly customizable. It has several features. Some of them can be seen on the panel displayed on this screen in the center. The panel shows graphically all the information collected from each vehicle. At the top, you can see the history of license plates identified by automatic number plate recognition, or the OCR system. In the middle, it is possible to see the captured images of the vehicle from different angles and different moments. The rear view shows the message displayed for the driver. These images allow a very clear visual identification of the vehicle. At the bottom, you can see the representation of axles identified by the system. It's also possible to see the weight of each axle and the weight of each group of axles as well. You can also see the type of each axle, if it has a single or a double tire. The first one is a single tire, the rest of them is double tire. The numbers shown in red are the weight values that exceeds the maximum allowed limit. On the bottom left, you can see the classification code for this vehicle, according to the Brazilian and international code. This truck, for instance, is a 3R6 type. Out of curiosity, in Brazil, we have to handle more than 60 different vehicle types for classification. It's a very challenging task. On the bottom right, you can see a screenshot with a graphical panel showing statistics. This shows the accumulated data of the day. The There are several different types of statistical reports, and new reports can also be easily created. Let's talk about this kiosk now. As you can see on the right, there is a photo of a self-service kiosk. This kiosk is installed on the waiting station. It is used to allow the driver to self-service if his truck is overloaded. This is another very interesting technology in the semi-automated inspection solution. The Brazilian authorities have few enforcement officers who work physically at several waiting stations throughout the country. To solve this problem, this project was a pioneer in offering a resource for officers to work remotely. Through the self-service kiosk, using software that is part of the entire solution offered by us, officers provide remote assistance to drivers. Drivers can present the necessary documents, and the enforcement officer at the operating center performs the necessary procedures. He can release or retain the truck. The main advantage of this is that one single enforcement officer can operate up to 4 waiting stations simultaneously. Next slide, Diego, please. But how about the accuracy of the high-speed waiting motion implemented in this case? To certify the accuracy achieved, tests were carried out in accordance with the procedures established in COST 323. 3 trucks with 3, 5, and 6 axles were used. You can see their photos on the right. The trucks' reference weights were obtained on a highly accurate static scale. In this case, there are 2 rows of intercom strip sensors for each lane. The table on the center shows the results. We had a total of 84 runs of the 3 trucks. You can see the table on top left of the center for all criterions, including gross weight, group of axles weight, single axle weight, and axle of group. The maximum error was under the maximum for A5 accuracy class. This is the most accurate class defined by this standard, as mentioned by John. In the top left, we have a box with the testimonial of Mr. Sergio Santillan, the president of Interviews, just validating the performance achieved. I think now I have another poll question, right?
Yes, Barbara, could you please release the second one? And I kindly ask you to all those attendees to respond to see what the result is. Please, Barbara. Okay. And just for remind you that you can pick more than one. And here's the relevant components when we are going to implement a new technology. And we know that cost is always on the list, and that we especially take care of it. So the idea is just, hearing more from you, how you can, manage and direct and receive some extra direction from you. This is very important for us to receive this type of feedbacks. Yeah, it looks like performance is almost there. And the amount of data provided is important as well, because we are talking about data collection, and this is why we can be more prepared to the future and see how exactly we can handle the next challenge using the roads in the United States. This is why we put the amount of data provided there. Prior experience means our technical history and how confident this type of technologies already achieve to generate results. Okay, I think we have almost there. A little more time, and then we can just move on. I think cost again. Yes, maybe we can move on, Barbara. Yes. Okay.
Okay.
So thank you, Barbara.
The next slide, please, Diego.
Okay. Here you
go. Toll by weight. Based on current technology of weighing motion and its capability, I pose a question. How could we implement toll by weight? Oh, this is not new that heavy trucks cause hundreds of times more damage to the road than passenger vehicles. And the damage grows exponentially according to the amount of overload. In many cases, the gross vehicle weight is under the limit, but the overload is concentrated in one or more axles. This is the cause of excessive road pavement degradation. Considering this information, tolling by weight could be a good tool to understand even better the road usage. And to make it possible, besides the legal allowance of that, this solution is ready to go. The solution is prepared for it. For instance, road users can be charged according to their vehicle's actual weight. Weight enforcement can be associated as well. The whole process can be fully automated. Another usage for high-speed weighing motion is a success case that we had with Arteris Group in Brazil. We installed a total of 40 lanes for data collection. This data was used to identify a percentage of overweight trucks, and this is a permanent tool to keep studying ways to balance the fare charged on the road. Next slide, Diego.
Okay.
Let's talk about the high-speed weighing motion direct enforcement. The trick here is to carry out weight checks directly on the highway with vehicles moving at normal traffic speed. As a result, it is no longer necessary to have a weighing station for slow or static precision weighing. The system performs the detection, weight measurement, and identification of all vehicles through pictures and automatic number plate recognition. If any overloaded vehicle is detected, the whole set of evidence is used for violation issuance. This is an automated process of enforcement. Considering the legal restraints and legal allowance, the direct weight enforcement is the most efficient and effective way for enforcement because it requires much less enforcement staff. It operates 24/7. Almost all vehicles are checked. As a result, it saves time and increases safety. We can save costs using direct enforcement. Fights unfair competition as well. The next slide, Diego, please. Let's understand where direct enforcement is happening. Basically, it's happening in the countries in the blue box. In Hungary, in Czech Republic, in Russia, and in China. China has, for instance, more than 1,500 lanes in operation. Operations started in 2016. Other countries in the green box are in process to start operations. Basically, this process is due to the legislation to get direct enforcement allowed. This is happening in Belgium, in Brazil, in France, and in Thailand, and other countries. Next, please, Diego. But what about legislation for direct enforcement? Each country is defining the regulation to be adopted, normally based on the international standards mentioned by John. The table to the right shows the numbers being adopted in general by the countries in general. In terms of accuracy, there are generally two distinct levels. One accuracy level which is more restricted, is for initial verification or type approval of the equipment. Generally, the maximum allowed error for gross vehicle weight is 2.5%. For axle measurement, the allowed error varies from 4 to 11%, depending on the country. The other accuracy level is considered for in-service verification, when the system is already installed for a while. For this case, maximum allowed error for gross vehicle weight is 5%, and for axles, it varies from 8 to 16%. The speed range for approval normally goes from 0.5 to 150 kilometers per hour, something around 93 miles per hour. The considered confidence level usually varies from 90 to 95%, but some countries are adopting 100% of confidence level. The accuracy of a high-speed varying motion system is totally dependent on the road pavement characteristics, as John said before. The achieved accuracy is the result of the combination of the pavement conditions and sensors quality and technology. In those countries where the 100% confidence level is required, there is a major challenge because no valid measurement can have an error over the limit allowed. If just one measurement is out the allowed limit, the equipment is not certified. In this condition, techniques must be adopted to identify deviation of measurements and disregard them. And then this is the key to solve this challenge. Next, Diego. Just to put in the real world, in 2018, we implemented a pilot of weighted direct enforcement in Brazil. A set of 4 rows of intercom strip sensors was used, a total of 8 strip sensors. The software system was implemented by our development team in Brazil. During the demonstration of the system, we had the participation of representatives from Inmetro, which is the meteorological authority in Brazil, and we also had the participation of representatives from ANTT, which is the National Transportation Agency. As you can see in the table, the tests took place with 3 trucks, with 3, 5, and 6 axles. The targets for maximum error were 2.5% for gross vehicle weight and 4% for any axle, as an attempt to comply with existing meteorological legislation. In 98% of the samples, the measurements were below the maximum allowed error, almost 100% of confidence level. But how to solve compliance with 100% confidence level? Oh, the solution is to implement a logic that identifies any abnormal weighting situation and invalidates these measurements. What exactly is abnormal situation? We identify abnormal situation when any vehicle movement compromises the measurement. For example, sudden braking, change of lanes, driving with the wheels partially on the lane. In this case, the measurements must be ignored. But the important thing is, currently, the direct enforcement is pretty new, but it is our reality and it is reliable. Next, please, Diego. Just complementing the benefits already mentioned by John, we have several benefits considering the future of high-speed varying motion. But we would like to emphasize the quality and accuracy of the data collection for long-term infrastructure planning, as well as for long-term pavement performance studies. Roadway operators can benefit with a more efficient and effective enforcement and screening, resulting in reduction of road maintenance costs. Vehicle operators benefit saving time and money because they can bypass the weigh station if they are complying with the rules. We have more safety for the drivers, for operation staff, and for the highway patrol. Once the whole process is much more automated, it can requires less enforcement staff. And of course, high-speed weigh motion inhibits the traffic of overweight vehicles, contributing to fair competition for transporters, increasing safety, reducing accidents, and minimizing pavement wear. Back to you, Diego.
Okay, thank you very much, Diego. And now again, just kindly ask you the last polling question for you all, and then you can open the Q&A questions and the chat as well. So Barbara, if you could help us, just for release the last one, please. Yes, I think we almost have the average voters. Yes, and then thank you very much. And we just going to open the Q&A questions and then the chat as well. Let me just switch. And then we can just see some of the questions that we have here. So could you explain a little bit more about the data collection that FTAA is able to do? Maybe Diego, can you respond to that question, please?
Oh, sure. Actually, we can collect a lot of different kind of information, like the number of axles. We can measure the dimensions of the vehicle, like height, width, length. Of course, the weight of each axle. We can read the license plate. We can read the RFID transponder if it has. So you can collect almost all possible information about the vehicle.
Okay, thank you very much, Diego. And we got some question from Stefan Larcara, sorry. What does that work with the super single tires? Maybe we can invite John to respond to that, John, please.
Sure. And if this question is asking about super single versus single and duals to differentiate those, it's really, to be technical, it's based on a waveform. So the waveform of a single and a dual tire are clearly different. So you can actually translate that through your algorithm to identify the two different tires. The super single tire has a broader waveform than a single. The challenge is resolving that waveform. And that's where the sensor manufacturers step in with the system integrators and get the best possible algorithms to differentiate the different tires.
Oh, perfect. Thank you very much, John.
So,
and then we have the next one is how could you adapt the high-speed weigh motion deployed overseas in order to implement it in the United States? Maybe Diego, could you help us on that?
Actually, as we are a software factory, we can use sensors like intercom, a very reliable sensor. We can integrate with different technology of sensors, 2D, 3D, LiDAR scanners, and with high resolution cameras. We can put all together, and it works it doesn't matter the country. It will work in Europe, it will work in China, in Asia, in the United States. We just need to comply with the regulatory demands. This is the barrier, but besides that, there is no technical barrier for that.
Okay, thank you, Diego. And also we are able to customize, so we are very open because, as we said before, we are a software factory, and then it's not so difficult to adapt as much as is needed. And also we have this Asen Alturk just ask, currently FDOT use high-speed wave motion. What does the FDA bring to the table that is FDOT is not currently using? Yeah, maybe here, Mr. Alturk, sorry, we are more saying about the high-speed wave motion up to 80 miles per hour. So this is the focus on our technology so far, and maybe Diego can jump out and help me to give a little more details, Diego. I think you are mute. Diego, you're mute, sorry.
Oh, I'm sorry.
Okay.
Actually, we can bring you all the cutting edge technology and features. You can use, I think that overseas and other countries, like in Brazil, it's very advanced, and in Europe, the wave motion is very advanced. And I think that you can, besides only the rating, you can put all together all the features. You can aggregate more features to the system.
Okay. So, and we got another one from regarding to legal metrology and standards. What is the status of wave motion standards in the States? Maybe, John, you can.
Yeah, I should probably check that. Yeah, there's a couple of questions here that I could maybe answer, but this one is in the middle. This is where I actually might request a contact after this presentation of attendees to maybe contact me, because we do have, of course, Handbook 44 with scales and sensors, and weigh and motion is actually being considered for legal for trade applications under, I think, Class 3 or 3L. The challenge there is meeting a 3-division error, which can really only be done at low speeds. So there is a separate tentative section that was created by Tom Carney with regards to really high-speed weigh and motion, and create a whole different set of accuracy requirements for metrology, such that states could certify weigh and motion systems to operate in the United States. Simply put, right now, one cannot certify a weigh and motion system for legal applications in the United States. And the reason is not so much because of the performance of the scales or systems. There's a variety of manufacturers that have constantly been improving their systems. It's just the standards don't currently exist for that, or they've not been accepted via Handbook 44 and implemented by the states. So there are many factors that drive that, manufacturers and integrators, and then of course the demand from people that would want to be able to certify scales or systems.
Yeah, and just I think we just proceed to the end of our section, but I think we have time enough to respond. Carl Francois, I'm sorry if I just spell your name, pronounce your name wrongly, but can you give a description of the type of a sensor using the high-speed wave motion shown? Maybe John, you can do that, or maybe Diego, either way.
Yeah, there's been a couple different high-speed WIM systems shown, but it usually consists of a single vehicle loop, rows of sensors that are either staggered, 2 rows, 3 rows, or 4 rows. 3 of those configurations were shown, and sometimes angled sensors, piezoelectric sensors for the single, super single, and dual. There's also a variety of other sensors that can do that functionality. So there's usually 3 in-ground sensors. There is a strive towards loopless operation. There's a strive towards visual classification of vehicles, but of course weighing will always be below the wheel. That's a description of some of the sensors. Above ground or beyond the WIM, to use that acronym, BTW, beyond the WIM, there's a lot of sensors that can add the value and automate the entire system. And I think that's where the value of the future WIM is largely going to come from.
Yeah, and I think we covered what is the evidence from your technical history that proves the benefit you are mentioned during the presentation. Maybe Diego, you just can very quickly say something about this question.
Oh, actually, it's based on the experience that we have here in Brazil, because authorities are requesting even more and more this kind of technology, because the benefits are, they are seeing the benefits. They are very worried about this and they are supporting the implementation of the system, the solution, because all benefits are very well welcome for all. I think it proves its benefits.
Yeah.
And with regards to direct enforcement throughout the world, intercom sensors have been integrated in many of those countries that you viewed, Russia, China, thousands of sensors in China. And they had a major overweight problem in China, as you can imagine, and that allows them to reduce the incidence of overweight, depending on what province they installed this in. And, you know, it takes a little bit of time, but that reduces the wear on the infrastructure significantly.
Yeah, sure.